All right. In this video, we're going to find arc length of this function x squared plus y squared equals 1 for y equal to in between negative 1/2 and 1/2. Okay. So given that our limits of integration are with respect to y, it looks like that we're given it in terms of y. Strong indication that they're wanting us to consider then this positive root of x. So if I solve this for x, that would result in subtracting a y over, and then taking the square root and considering only the positive branch of the square root. So if we do that, get 1 minus y squared. Okay. And so this is our function x of y that we're going to consider the length of. So L in this case is going to be in terms of y. But we have our limits of integration negative 1/2 to 1/2 the square root of 1 plus dx dy squared dy. Okay. So just like before, I'm going to work on this inside part first before I plug everything in. So I'll need to take the derivative of this with respect to y, and then I'll square that, and then I'll add 1 to it and see what simplifies. Okay. So x dx dy equal to, so this, the derivative of this with respect to y, I'm going to have a 1/2 and then 1 minus y squared, and I'm going to reduce the power of the outside function using the chain by 1, so that gives us a negative 1/2. And then taking the derivative of the inside is going to give me a negative 2y. And then that's all that there is. So the negative 2 and the 1/2 will cancel. And to clean up the negative power on the exponent, bring that downstairs. So this simplifies pretty nicely to negative y square roots of 1 minus y squared. Okay. So now I have dy dx. Now I want to square this. So dx dy, sorry. dx dy squared equal to, looks like negative y over 1 minus y squared. A lot of squared floating around. So this will give me a positive y squared here, and then the square root and the square are going to undo each other. So it looks like this will come out to be y squared over 1 minus y squared. And so that's this part. And so now let's go ahead and throw in the plus 1 there. Okay, so 1 plus dx dy quantity squared. So this is everything under there. We're going to have 1 plus. So the dx dy squared is this thing over here, which is y over 1 minus y squared. Getting a common denominator. This 1 is going to be multiplied top and bottom by 1 minus y squared over 1 minus y squared. Imagine that those as a unit would be reducing to 1 plus y. Should be y squared. I'll be careful there. Y squared over 1 minus y squared. Okay, so now I have a common denominator. Notice that we have a 1 minus y squared plus y squared, so those y squareds are actually going to cancel out. I thought that would happen. That's why I didn't realize I missed the 2 there until I saw that. So uh, sometimes anticipating certain things can help you catch a mistake. Okay, so this is going to be just 1 over 1 minus y squared in this form. Okay. All right, so this looks like I can simplify anything, and that's not a perfect square. So let's go ahead and go back to our integral then. We have L is equal to the integral from negative 1/2 to 1/2 the square root of 1 minus y squared dy, which you can also imagine as being equal to negative 1/2 over 1/2. So the square root of 1 is 1. So I can actually write this also as 1 minus y squared, or dy over 1 minus y squared. Okay. I do that, or I write it in the suggested form because this is a really common integral with trig subs. Okay. In fact, it's screaming at us to say, okay, well, let's choose let y equal, uh, since this is a 1, this is going to be sine of theta, which gives me then that dy is equal to d theta, and the derivative of sine is cosine of theta. Okay, so let's change the limits of integration as well, since we're going to evaluate this eventually. So what value of sine of theta would give us a positive 1/2? Well, if you think about the unit circle, sine is positive 1/2 when it's equal to pi over 6. And likewise, it's equal to negative 1/2 when it's equal to negative pi over 6. Okay, so those will be your two limits of integration for theta. And then I'm going to plug everything in. I also want to recall that cosine squared theta plus sine squared theta is equal to 1. So if I subtract this sine squared theta over, you're going to get cosine squared theta is equal to 1 minus sine squared theta, which is the motivation for this, because you can see foreshadowing that those two are going to be equal, giving us the cosine squared, and then some nice things are going to happen. So let's go ahead and plug all this in and see what happens. So we have the integral from negative pi over 6 to pi over 6. We have dy, which became cosine theta d theta. Okay. And then we have the square root of 1 minus sine squared theta, plugging in y equals sine theta. So squaring that, you get the sine squared theta. Okay. And now this 1 minus sine squared theta we saw earlier is equal to cosine squared theta. So I can actually simplify this. Okay. So this is d theta cosine theta over the square root of cosine squared theta. The square root and the square are going to cancel out. And I think you can see how quickly this is going to collapse now. D theta over cosine theta. Those canceling out, you get cosine theta. Okay, so those reduce to 1. So this is just the integral of negative pi over 6 to pi over 6. That's over 6. Not fun. D theta. So this is theta evaluated from negative pi over 6 to pi over 6. This is pi over 6 minus a negative pi over 6, which gives us a pi over 6, pi over 6. That's 2 pi over 6 or pi over 3. Okay. So the arc length then for this problem is pi over 3. All right. I hope that was helpful, and I'll see you in the next video.